Imagine waking up not to the gentle glow of dawn, but to a sun that has barely moved since you went to sleep. The light outside is exactly as bright as it was 8 hours ago. The shadows haven't lengthened, and the air hasn't cooled. This isn't just a long summer day. This is the only day this side of the planet will ever know. In this strange world, the fundamental clockwork of sunrise and sunset that has governed existence for billions of years has ground to a halt. One half of the world is plunged into an eternal, searing day, and the other into an endless, frozen night. This isn't just a flight of fancy or a scene from a science fiction movie. It's a genuine cosmic reality known as tidal locking, and it is likely the norm for billions of planets across our galaxy. Today, we are going to explore the silent revolution of tidal locking, how it shapes the moons in our own backyard, why it might be the greatest challenge for alien life, and the terrifying question of what would happen if the Earth's own rotation finally gave up the ghost. To understand these divided worlds, we first have to understand the invisible chains that bind them. Every time you look up at the moon, you are looking at a tidally locked body. You have never seen the far side of the moon with your own eyes because the moon takes exactly the same amount of time to rotate on its axis as it does to orbit the Earth. It's a perfect synchronization. But why does this happen? It all comes down to a gravitational dance. When a smaller body orbits a larger one, the gravity of the larger body doesn't just pull on the center of the smaller one. It pulls harder on the side that is closer. This creates what we call tidal bulges, slight stretches in the planet's shape. If the planet is spinning faster than its orbital period, these bulges are dragged ahead of the gravitational line of sight. The host star then pulls back on those bulges, acting like a cosmic brake. Over millions of years, this friction slows the planet's rotation until one face is permanently locked toward the star. Now, we often think of the moon as just a spectator in our history, but the fact that it is tidally locked to us, while we are not yet locked to it, is the reason we are here. The Earth and Moon are often described as a double planet system. The moon's gravity acts as a stabilizer for Earth's axial tilt. Without the moon's presence, the Earth's tilt, the 23.5 degrees that gives us our seasons, would be chaotic. Scientists like Jacques Lasker have shown that without the moon, Earth's tilt could swing wildly from 0 to 85 degrees. Imagine the North Pole suddenly becoming the equator every few thousand years. The climate would be in a state of permanent cataclysm. In a very real sense, the moon is our climate regulator, keeping our world steady enough for complex life to evolve. But as we look beyond our solar system, the story of tidal locking becomes much more extreme. Most of the stars in our galaxy are red dwarfs, smaller, cooler, and dimmer than our sun. Because they are so cool, their habitable zone, the area where liquid water can exist, is much closer to the star. This creates a trap. If a planet is close enough to be warm, it is almost certainly close enough to be tidally locked by the star's massive gravity. Take Proxima Centauri b, our nearest exoplanet neighbor. It sits right in the habitable zone, but it is likely locked in an eternal day-night split. For a long time, astronomers thought these planets were uninhabitable. The logic was simple. The day side would become so hot that the atmosphere would boil away, and the night side would become so cold that the air would freeze into solid ice, leading to a total atmospheric collapse. However, recent climate models suggest a more hopeful scenario. If a planet has a thick enough atmosphere or deep enough oculular, heat can be transported from the day side to the night side. This creates a terminator line, a permanent albedo ring of Alacacranlock where the temperature is just right. Imagine a world where the sun is forever stuck on the horizon, casting long, golden shadows across a landscape that never gets dark and never gets truly bright. This terminator zone could be the most common real estate for life in the entire universe. But life on such a world would face challenges we can barely conceive. On Earth, almost every living thing has a circadian rhythm, an internal biological clock tuned to the 24-hour cycle of light and dark. It tells us when to sleep, when to hunt, and when to repair our cells. On a tidally locked planet, time, as we know it, doesn't exist. There are no days, no months, and potentially no seasons. How would evolution adapt? Would alien life even have the concept of sleep? Perhaps creatures would evolve to migrate, traveling from the scorching day side to the freezing night side to rest, turning a rhythm of time into a rhythm of space. Or perhaps they would develop biological clocks tuned to the flares of their star or the atmospheric tides of their world. On Earth, we see glimpses of this in deep sea creatures or organisms living in lightless caves. They prove that life finds a way to keep time even when the sun never shines. Then there is the problem of protection. On Earth, our magnetic field shields us from deadly solar radiation. This field is generated by the dynamo effect, the rotation of our liquid iron core. If a planet is tidally locked and rotating very slowly, can it still generate a magnetic field? This is one of the biggest questions in astrobiology. Some scientists believe that tidal heating, the internal friction caused by the gravitational tugging, could keep the core liquid and active enough to maintain a shield, even with a slow rotation. If not, any life on the surface would be at the mercy of the violent radiation of its host star. When we look at the Pluto-Charon system, we see the ultimate end state of this process. They are mutually tidally locked. They both show the same face to each other forever. It is a hauntingly stable configuration. It makes us realize that Earth's current state, where we spin freely while our moon is locked, is just a passing phase in cosmic time. Eventually, billions of years from now, the Earth's rotation will slow down so much that we, too, will be tidally locked to the moon. Exploring these what-if scenarios forces us to confront how deeply our lives are tied to our planet's rotation. We take the 24-hour cycle for granted, but it is the fundamental engine of our biology, our weather, and even our psychology. It creates the rhythm of our societies. As we search the stars for a second Earth, we must realize that our world is a rare jewel of stability. Most habitable worlds out there are likely divided, split between light and shadow, heat and ice. They are worlds where the sun never moves, where time stands still, and where life must learn to survive in the eternal alaka-karanalak. So the next time you watch a sunset, take a moment to appreciate the simple spin of our planet. It is that rotation that gives us our world, our time, and our future. What do you think? Could a civilization thrive on a world divided by eternal boundaries, or is the 24-hour cycle a requirement for a unified global perspective? Let me know your thoughts in the comments. If you found this journey through the cosmos fascinating, make sure to hit the like button and subscribe for more deep dives into the mysteries of our universe. Keep looking at the stars, and remember, even in a universe of locked worlds, our perspective remains wide open.